through the workshop I did on how to use NearPod to make sure that your students are being active learners in your classroom. A quick shout out to Ms. Perez, who was the first person who mentioned NearPod to me this year, back in August. And I was a little bit skeptical of using it, but she was very convincing. And because of her, I looked a lot more closely into how to make this work in my class. So thanks, Ms. Perez. Before we get going, I thought it would be valuable to just explain what I'm talking about when I say active learning. So the one positive thing that my master educator, my first master educator in DCPS did for me was introduce me to whole brain teaching. And it's a whole like philosophy with a bunch of different methods and things you can do. But the two of the biggest takeaways for me were that one, when we are learning, we learn way better if a lot of different pieces of our brain are involved. So simply having someone listen to a lecture is a really ineffective way to teach. And so making sure that students are moving, they're creating, they're speaking, they're acting, they're drawing, the more components in a given lesson, the more rich the learning experience, which is kind of obvious, but also hearing it and reading it, seeing it helped. And then secondly, to not lecture longer than a minute without having students process or practice the information in some way. And so for me, that was a shift. I realized I often lectured like 5 minutes at a time, maybe even longer, before having students do something. And so to really chunk your teaching in way smaller pieces and having practice all along the way. Okay, and so then in this virtual space, it took like a whole new shift in the way I was thinking about things. Like, how can I make my students be active learners when I am sitting here looking at this, piece of equipment and not even seeing the faces of my students in most cases? So NearPod is a really powerful tool for that. So if you look on the right, that's the sample deck. And one thing to notice is that there are activities embedded all throughout that deck. So every poll you see, every draw, the field trip as well, those are places that were put in place so that students would be engaging with the content explicitly. So at the beginning of my class, students see a slide that looks like this. This slide was improved as a result of a shared observation that the science department did. Ms. Foley really encouraged me to have the link to the NearPod and the code right on the screen instead of me trying to triage students getting there in the chat. And so I'm really thankful that I changed to this method. It took a couple extra clicks and, one added thing to my classroom routine, but it's well worth it. And I also, in the workshop we did, I just mentioned, I'm not the sage on the stage. I'm just learning this too. But I have put together a Padlet that I will include when I give this over to Ms. Howard. And so if you're interested, go to that Padlet, you'll see all the information really from this NearPod you're about to go through on one Padlet, and feel free to add to it. Feel free to ask questions, answer questions. It could be a living document. Okay, so now I am going to share my screen. And here's the NearPod. So we started out by just kind of thinking about, okay, where are you at and what are you looking for? This is a collaborate board here. So a bunch of people who were with us submitted their answers to those one or two questions. Okay. So that was a collaborate board. And what I'll do throughout this workshop is I'll name the activity and then, explain some applications of it and then actually show some. So for collaborate board, you could use this for any warm up to get answers to a question. You could have students attempt to explain content so that they can get that quick feedback, and having other students hearing that feedback that they are receiving can also support them in writing their own explanations or starting to put their own words together. You can solicit all ideas students have about any topic. And my favorite is actually peer critique, because the teacher is in control of, like declining any comments that aren't appropriate, but it is this, you know, public forum. Students are able to see a whole lot of responses at the same time instead of sharing one critique at a time. Two things to note. One is that I've noticed the Collaborate board completion doesn't seem to factor into the % complete in the NearPod report. So that's one thing to know. And then the second is that I've actually tried to stray away from Collaborate board for opening up class, generally because I prefer Drawits or matching pairs, because in both of those on the back end as the teacher, you're able to see who is doing what. And with Collaborate board, you have to wait for something to be submitted before you're confident that a student is active in the platform. Okay, so here's an example of that critique I was mentioning. So students were supposed to be making Flipgrid videos on a topic. Some students had submitted their work early, and a couple of them were super strong. One was so-so. And so I asked them if I could share their videos and have students critique their work in order to help them understand how to do the assignment. So what I did was I shared Mr. Herr's acronym KISS for the feedback. So their critique was supposed to be kind, important, specific, and short. And so on these Collaborate boards, students submitted KISS feedback for each of the 3 videos that we watched. And at the end of the day, what I was able to do was then screenshot those Collaborate boards and send them in an email to the student who had been willing to be vulnerable and share their work. So they got a bunch of positive feedback from their fellow classmates. They did get critique, like, you know, things to improve as well during class, but I did not send them a whole boatload of like, fix this, but I did send them all the like warm fuzzies because I wanted to really reinforce like how grateful I was and proud of them I was for taking the risk to put their work out there in front of their peers. Okay, web content. So my favorite use of this web content activity is actually Padlet, which I didn't even realize was possible until I saw Ms. Batts do it in our equity training. So I was like, yes, because sometimes the Collaborate board is just not enough. And so Padlet has a lot more functionality, a lot more options. And so I do use that occasionally now. I've also used web content for an Aspen link if we're going to be analyzing grades on a Drawit, for example, but Aspen's linked in the upper corner so that students can get to it very easily. But you can use it for any website you want. I haven't noticed any that are blocked. Probably YouTube is, but not much else. Okay, so here's the Padlet I mentioned at the beginning of the workshop. On the left here, you see that information about whole brain teaching. And then these are the different activities I'm going to go over. So Collaborate board, matching pairs, video poll, Drawit, web content, we already did, and other. So other is where this NearPod is linked. And there's also another example linked here too. This one shows a full lesson. So the current NearPod is like really choppy because I'm showing a bunch of examples of each activity, whereas this one here is like one cohesive set of activities. Okay, so the next activity I'll discuss is matching pairs. As I mentioned before, I really like starting class with matching pairs or Drawits because you can see who's working, who's not. And you can also give support. So for example, if you see someone has made 20 tries but haven't made a match yet, then you could be like, hey, so-and-so, can I help you find a match? And then you can lead them with some, you know, leading questions so that they make their first and or second pair. Some ways that I've used it are like vocab definition. You can also do model description. Any details about a concept, for example, when we were studying conductors and insulators, one of the questions was like, when you touch an insulator, it feels, and then the other side said warm. So they had to match those 2 sets of words to make a coherent idea. Math problems and solution would be another one. Okay, so here's what this one looks like on the student side. So you can have directions, but this particular one, students were matching element symbols and their names. And then of course, like if they got one incorrect, for example, maybe they had a hard time figuring out what FE was. You know, they're getting that immediate feedback right there. Okay, this one is matching what we see when we look at different candies with their molecular structures, so the macro and the micro levels. And what I found is that students were pretty good at intuitively being like, oh, okay, that's a match, and that's a match. So that was kind of cool. And next. Okay, so for practicing molecular structure, I had a bunch of molecules that I made and other ways of showing molecules and their formulas. And so students had to look closely. You also can zoom into pictures in case you're wondering about that. Students can click on the button to see the pictures more largely. And so they had to work their way through this assignment as well. Students struggled with that one a little bit because it was our first introduction to molecular structure. And so another nice thing was to take a screenshot at the end. And so that way you can show, okay, here are all the pairs. What was a pair that was pretty easy for you to make? And why? You know, what about it was easy? So talk about that. And then what did you struggle to make? For this particular example, it got surfaced that the HCl, for example, like that L is kind of ambiguous. Like, is it an L? Is it an I? And so students struggled with that. We also talked about key color because some of them, like the dark green and black, were hard to distinguish between. So a lot of rich conversation came out of talking about what was difficult about this. I included this one for a couple of reasons. One, so the whole theme of this class was going to be about extended molecular structures. But we had also had an extra credit assignment where students could make rock candy and show a Flipgrid video of their results. The only 8th grader who had taken me up on it was Willow, and so I wanted to celebrate her. So I showed her video later in the class, but I also had the 2 screenshots of her and me. And so, like, you know, students kind of quickly got these. And then they were also looking at these 2 different kind of more complex molecules than what we had been working with previously, but it was still all the same techniques used to understand what they were looking at. So the molecular formula, the number of atoms present, these you know, diagrams or models of the molecules. Okay. This one, a lot of examples, but I don't know. I was hoping that by seeing a lot of different examples, it might stimulate something in your brain for your class. So in this one, I've got a lot of drawn models of solids, liquids, and gases, and then characteristics of those 3 states of matter that students had to like read carefully and match. So one example, so like the model ones, right? They match to the picture. So model of particles in a warm liquid. So there's actually 2 liquids here, but this one is the warm liquid. So that'd be a match. And then bonds, weak bonds, those are in liquids. Bonds between molecules in liquids are weak. Okay, but of course, if they got one incorrect, they would be told that, and then they would be able to try again. Okay. And then I did time one toward the end. And this is that example that I had mentioned about conductors versus insulators. So if a material is a conductor, it will melt an ice cube. So it's a conductor. That ice cube is going to melt quickly. We had done something in previous class where we observed that, but this was like a reminder of that connection between conductors melting things quickly, insulators melting things slowly. Okay, the next component or activity that I've included is video. So I've really liked to make my own mini lessons once a week. And the reason why I do that is I'm able to get like a clean, concise experience for the students. I typically am filming from my bedroom during the day teaching, but the kitchen is where a lot of the stuff I need for science is. So yeah, so I like make one clean mini lesson. I try to keep it between 1 and 5 minutes. I embed activities, although I don't always because it's a little bit choppy to go between activities and the video if I want to share it in the full class. So I just generally try to keep the video 3 minutes or less. Anyway, so you also can feature students, like I featured Willow. YouTube, of course, has all kinds of goodies there. One important thing about YouTube videos is that, you know, they don't talk well with DCPS computers for kids, so, or internet. So I know that there's a lot of YouTube converters out there. It is important to convert the video so that it's no longer YouTube and it's just a file. If you want students to be able to reference them on their own, like watch the video on their own during class, and or you want it to work when students are accessing the lesson outside of class time. So if you're not showing it to them on your, you know, by sharing your screen, you want to have it downloaded and not a YouTube file for students to access. So here is just a quick example. Okay, so that could be an example of a mini lesson. And then I could also click Students Play. So if I click that, then I can show you over here on my student version. I would click play. Okay, so that's Willow. And then here's just one video to represent, and I'm going to have the student version play it. The power, you know, of having small clips for students to watch on their own and then do something with afterwards in class. Okay. Okay, so that leads me right into poll. So poll is kind of, I feel like one of the earliest like technological advances of classrooms, or that what people have been pushing to use. But you could do like traditional multiple choice. You could do polls of student positions on content. You could solicit information from students, like who will be the chat monitor, anything like that. So after that video that you just watched, I had students answer this question. So, you know, why is the boy's tongue sticking to that flagpole? Is it due to conduction, convection, or radiation? And so what it looks like on the student side is this. Okay, so they can select their answer, submit, oops, and then that would inform me on this side that they had entered their answer. Okay. And then Draw It is my other favorite tool. So matching pairs and Draw It. You can do all kinds of things with Draw It. Coding text, editing text, math problems, data analysis, providing lots of options for students to pick, and then just having them pick one or two, diagramming, checklists, all kinds of stuff, and I'm going to show them all. So, or that I've come up with. Okay, so after watching that video and doing the poll, the next step I had students do in the lesson was to draw an arrow to indicate the direction of heat transfer in that phenomenon. Mr. Dashner was good enough to complete the exercise correctly for me. So I've just gone ahead and shared his example in the live lesson. So if I look over here in my screen, my student screen, I would see what Mr. Dashner had done. Okay, next. When we were using the videos, the Flipgrid videos, to critique and to help students understand how to use this rubric, or not this rubric, but this checklist here, this is what they had in front of them while the video was playing. And so students were able to just use a Draw It to check off, you know, they did this, they did this, they did not do this. You know, they could mark it up however they wanted to indicate what they were seeing or hearing in their peers' video as we watched it. And you can see some completed examples there. This is the grade analysis that we did. So in the student version, like they could click right here to go straight to Aspen. I have some directions for them on how to find their assignments. And then here's a Draw It that they could use. You can also do text boxes, so you could move the text box here. I try to get students into the habit of knowing that they can do one text box, right? It doesn't need to be perfect. Like I'm not expecting beautifulness on my So anyway, they could enter their grades, and then I was able to watch them doing it on my side. I also had printed out the grades, so I had them as a reference to make sure that we were both looking at the same stuff. Okay, this was coding data. So I provided students with the data set, and then they were told to use these colors to color code the data sets, because sometimes, you know, eyes pick up on patterns better when they're in color. And then for students who finished that initial task, there was also this task at the bottom that they could make a text box for. And you know, write their ideas here. This was like the more advanced level of blooms here. And so I could get students who finished the initial data analysis like onto the more complex task. And this one, students are analyzing, well, they're putting together a data table based on unknown values. So like this experiment we had done had these materials. So I made sure that those materials were present in this larger list of thermal conductivities. And so students were to write in the thermal conductivities for each material and then answer the question below. Next. Here are 12 vocabulary words that were related to what we were talking about. And so students were told to circle the 2 terms most essential to explaining the concept. What I really liked about this one was that, first of all, a lot of students, like almost everybody, did this one. Sometimes that's not the case, but students felt very comfortable to like take the risk here. So, you know, they freezed 2 vocab words. I was able to see what was getting circled, you know, do some narration about it, have call in students to tell us why they had chosen X, Y, Z, and I knew in the background what they were going to be saying. Okay, this is an example of a draw it exercise that I kind of like molded my mind to like figure out how to do, if that makes sense. So like I knew that I was going to have them doing a task in Canvas where they had to analyze graphs, but I wanted to make sure that their eyes identified the pattern that I knew that I expected them to, and I realized maybe I was like making a leap between my expectation of their abilities and their actual abilities. And I was so glad I did, because this ended up being like a really rich conversation that helped students quite a bit. So anyway, they had to look at the 4 graphs and circle if the given substance was a conductor or an insulator. So the only work on this slide that students need to do was circle conductor or insulator. And so I found that having students circle things on these slides is definitely the easiest. They are getting better with text and writing, but it is easier to just like circle things messily if you just want quick checks of what they know. But anyway, so I could see like who was trending in what direction for these 4 substances, and we had a lot of conversations around what is the pattern in the way these lines are behaving and which items would be considered a conductor versus an insulator. Okay. All right, and then we write in science. So in the live workshop, a comment was made that, you know, this acronym of RACE maybe is not as sensitive as it should be, especially given the climate of our country and world to a large degree right now. And I went on record of saying, I don't like that acronym anyway. So maybe as a staff, we can change it, but like my own preference is CER, claim evidence reasoning. I believe that the whole science team feels that way. And the reason why we do RACE is because the English department uses RACE and we're trying to be consistent. But anyway, as a school, maybe we could change it over to claim evidence reasoning or ABCDE. I've done that one too, like assertion, background, citation, discussion, end. So anyway, please don't be turned off too much by what this exercise is asking students to do. But I've provided an exemplar here, like, you know, perfect piece of writing to respond to the prompt that I put in this little box right here if students wanted to reference it. And I had them coded. So I wanted them to see that the claim where they restate and answer the question, that is the first sentence, and then the citation, and then the explanation at the end. Getting students constantly to like identify where these pieces are in writing over and over and over again, with the hope that their writing will get stronger as a result. That was one. And then, oh, I don't have it here, but what I did show after that in the sequence for that lesson was a correctly coded paragraph. It was helpful to have that on hand ready to go, because not all classes did I have a perfectly coded paragraph. Okay, here is an example of us now looking at a claim to that question or that prompt, and it's got like it's like the perfect mistake, because I believe maybe it was Miss Bats who said this, I forget, but yeah, I pulled it. It's a real piece of writing, and it has so much great vocabulary, but it's missing some key phrases that make it not as strong. And so this particular class was a day where I was doing it on my own phone, so that I knew I was going to get an example, a markup that was like all of the pieces I wanted. If I was going to do it again, I would have actually just screenshotted that instead of doing it 5 times every lesson. But anyway, so editing student work together on the screen on a draw is a great thing, I think. I enjoy it. And then here is an example where students had done something in groups in PowerPoint, and I noticed that there were some consistent mistakes being made. And so for the warm-up the next day, I had them circle each error on this group's slide. So they could use the pen to circle and identify places where a group had made a mistake. And this was actually no group, like this was me compiling all of the common errors onto one slide. And then this is kind of just a more traditional like worksheet on the computer. So I used to hand that out on a little half sheet of paper, and now I had students do it for a draw it. And it looks like this, and they could just use either a text box or a pen to answer, put the number of atoms and elements there. Okay, so now we're going to start transitioning into poll, or we already talked about polls, that's what it is. So I wanted to show this one because it leads to what we're about to do next, but students were shown these 2 models. They could click on here to see it bigger, and then they needed to identify what state of matter is trying to be represented. And then after that, they were shown those same 2 pictures. We confirmed, yes, we're talking about a solid here. And then students were to use the draw it to check off which characteristics of a solid were present in that model. And this was to help them prepare for talking about what models are showing and their limitations. Okay, and so after we did that, then students had to go compile materials where they are to make their models, and they needed to then show me their model, but then also on this checklist, check off, okay, so what characteristics of a solid in this case is your model showing? Like just check off what your model is showing. And it's okay if it's not everything on the list, but let's identify what your model's limitations are. Okay, here is an example. Oh, oh God. Oh yeah, okay, we are at the end. So then the last thing, these VR field trips, like at least for my class, like they're not the cornerstone of the class, but they are kind of fun to add in if they happen to be relevant to what you're doing. So for example, for heat transfer, convection is a form of heat transfer, and wind is convection. And my favorite place where wind happens is the kite surfing capital of the Western Hemisphere, Cabarete in the Dominican Republic. So I was like, let me see if there's a little trip to Cabarete we could take before looking at the video. And sure enough, there was. So I shared this with the kids, and they enjoyed looking around at the scenery. And I was like, okay, who can tell where this is? And a couple classes students keyed in on these kites here that say Cabarete on them. But anyway, it was just like, again, like in the framework of whole brain teaching and being an active learner, it doesn't mean that like every time that they're engaging their brain is like deeply embedded in the content, but it's like keeping the brain awake and on and moving. And so something like this can help just kind of, you know, rehook kids during the lesson. And I think we have reached the end. Feel free to reach out to me with any additional questions, but otherwise I'm going to stop recording and be done. Thanks for watching.